Hi everybody, Glenn here, and here we're going to do a small tutorial on an asteroid. So it's going to be pretty simple stuff. I'm going to be primarily working in SOPs, so it's going to be geometry operations, displacements, there's going to be shading, rendering, lighting, and a few different other concepts we are going to be looking into, like light linking and such and so forth. So without ado, let's make a start. So I'm just going to click a sphere, hit enter, drop it in RC. Now here we are, we have our sphere. We may as well call it asteroid, of course. Now when I'm looking at this, we are now using a polygon mesh, as it now comes in as default. It's polygon mesh in Houdini now. The problem is we're going to be doing displacements, and this has a north and a south pole, which I'm not particularly fond of, so I'm going to go with polygon, which seems a bit bizarre because it triangulates it and we will be subdividing it. But the way Houdini does things, the subdivision of these triangular polygons here will come out as quads in the end, so that's not too much of a problem. So as I like round numbers, let's go with a radius of 1 across the board. Frequency 10. Okay, we need something to work with. I'm not going to go too detailed at this moment in time. So we're going to jump inside, and we have our sphere here. I'm going to drop a transform node down because I want to scale it on the x-axis, I believe. Yeah, on the x, and I'm just going to non-uniformly scale it up to give us this sort of shape. Okay, now I'm going to add a rest position SOP, because we're going to be displacing on the well, no, without a rest SOP we'll be displacing on the point positions, and as this will be animated, the point positions will be changing over time. So you have px, py and pz. These will be changing because it's animating through space, so these positions will be changing. That's not good when you come into displacements, specifically shading displacements, because these values will be changing. What you'll get is a swimming texture effect, or swimming displacements, which we don't really want. So with this we'll go with an attribute VOP straight away and dive straight into displacing our geometry. So we'll jump in. Now, as I just mentioned there about the point position constantly changing, so what we'll do is we'll just bring in a parameter node. Okay, and this parameter node is going to be importing the rest position, and we'll just label that rest. Okay, I'm going to make it invisible because we don't need to access it from this level here. As you can see, it's not there. Take invisible off, jump back up, you can see it's here. We don't want anybody changing this, that would be bad. If we middle click on here, you can see we have 2 point attributes, position and rest, and as you can see, rest is 3 floats. So we can either use it, keep it as a float and bump it up to 3, not with this node obviously. Now 3 floats vector, or we can use a vector, you know, it's entirely up to you, to be honest. I'm just going to drop that as a vector. Okay, so displacements, what do we need now? So I'm going to displace it with a turbulent noise just for now. It's pretty much going to be the same setup as what we'll do in the shading. Now we need to displace along normal. Okay, so let's add this into here, into the position, the output of the noise into the amount, and P, funnily enough, if I don't collapse that down, P into P. Okay, and that shouldn't have done that. Why has it done that? Yeah, just a graphics failure by the look of that. Okay, so here we have our displaced geometry. Right, okay. I don't really want to faff about jumping in and out of here, so I'm just going to right click on here and I'm going to go Vex VOP options, and I'm going to create input parameters, which will give us our parameters here. And I'm only bothered about the scale one here, so I'm just going to middle click on scale, promote parameter. So if we jump up now on this node, we've got everything we need to access everything that we need basically. So let's go with a smooth shaded for the time being, so we can kind of see what's going on. And I want a... I see the rest positions showing up. Did I forget to invisibilize it again? I did. There we go. So it's not there anymore. Cool. Right. So what I'm going to do is I'm going to alter frequency on this to a fairly low frequency and scale it out. We've got some nastiness going on there. Some nastiness. So let's check out some of the other stuff. Okay, that's interesting with a little bulb here. Sparse convolution. That's okay. Bit OTT for my liking. So alligator noise. I'm kind of liking that. Let's see what we get. The roughness. Attenuation. Let's see if there's. Let's have a look at that, because I want it quite bulbous initially. That's quite bulbous, so that'll do for the time being. Okay. Now, as I said, we were going to subdivide this, so let's subdivide this. Pop it on there, and if you look, all the tries are now into quads, so that's fine. It's pretty cool. Depth's not enough. We need 2, so we should be up to about 24,000 polygons now. We are. And now I'm going to do some medium sort of displacements, and the smaller stuff that'll be built into the shader that we will be building shortly. So it might be an idea to start naming these nodes, the important ones, like large disp. This could be med disp. Jump back inside. Same thing going on again. We'll get parameter, make that invisible. Again, I'm going to import the rest position, and rest position. Okay. And again, let's go to 3 floats vector. And turbulent noise. We're going to go with the turbulent noise again. I think so. Splice along normal. Okay, so I'm kind of doing this off the cuff because any problems that arise or issues we run into and stuff like that, we can figure it out here and there, rather than having a pre-written hey, look, this is what I did. Dial in 10 into this value. That don't make much sense when you're trying to show people how things can be done and go on. I'm certainly no expert, but yeah, that's it. Original purling. That's looking good for me. I'm gonna increase that a little bit, and then scale. I'm gonna bring that down. I don't want any broken overlapping polygons, and we're getting very close there. So I don't want to push it much further. See, we have some issues here, so I'm just going to back it off just a tad. We're going to lose some definition. How much have we lost? Yeah, not a great deal. There's still a fair bit of definition there, so that's okay. I'm quite happy with that. So let's do this again. Let's swap and input scale promote parameter. So I have it up here now, and as far as I'm concerned, that's looking pretty good. It'll do. Looks like it's got a fat backside there, bit of twerking going on. So with that, let's jump up. So we now have our asteroid, our base asteroid anyway. So, and yeah, 24,000 polys. So yeah, it's just a medium res item there. So that's not much of a problem. Now. Normally I'd move on to sort of like the planet sort of thing, but I'm not going to do. I'm going to jump straight into shading. The planet we shall be utilising. Let's add a new pane, material palette. We shall be using the generic shaders here. For that, I'm not going to build into that, but the asteroid, a bit different. I want to work on that specifically, so we're actually going to build a shader from scratch from that. So what I'm going to do is I'm just going to drop in a camera, just so we can actually get some real-time updates while we're working. So I'm going to go to render, create render node, and Mantra PBR, if I could actually speak. So we have a camera, we have a render node. Now we need some form of lighting. So I'm just going to control click a spotlight from whichever angle you want. Makes no difference. And over the network, I'm going to hit L just to light it all up. So without further ado, let's jump to render view, and we're already assigned Mantra 1. We need to assign the camera we wish. I'm going to open this up. I'm going to override the resolution because I don't want to be rendering at 720p for test renders. Hit render, and there we are, Asteroid. Thank you for joining me. I hope you enjoyed it. No. Okay, let's go further than that. Let's jump over into shops. I'm going to put down a material shader builder. Okay, we may as well call that Asteroid, because it is. Now I'm going to assign this just by dragging and dropping into the render view here, and everything will go black. Boom. So where's it all gone? What's it all done? Over render view, if you hit A, you see the alpha channel. It does exist. Press C to go back to diffuse. Yeah, so the reason why is because there's beggar all going on in here. Okay, not a stitch. So yeah, the easiest way to get stuff showing up is don't start building your diffuse network straight away. Stick some lighting in. The shader has to have light calculation to be able to see the object. So drop a Lambert down. Okay, don't need any fancy ones. You could put down lights, different lighting VOPs and stuff like that. And if you look at the Lambert, it gives you a diffuse colour here, which we'll actually be piping other things into the diffuse. So this here will be ignored, but for now we'll connect that up and you will get your render back, because now the light is getting input and it's calculating the well, basically it's just calculating the light off the surface points. So we've actually got a network in there that's generating the lighting part of the shader, so we can now see it. So less waffling, let's move on. With that, I'm going to stick down an environment light, go back to render view, and it's going to blitz it out entirely. I'm going to drop the intensity down significantly. This is space, so you need some level of contrast, but I want to have some level of GI in there, so I'm going to call this Asteroid GI. Okay. Right, shop. Asteroid. Let's jump in. So we need to think about diffuse colour. I'll just take a quick drink. Okay, diffuse colour. Depending on what asteroid you want to go for, depends on what colour is going to be driving it, but it's generally going to be a mix of colours. So I'm going to go with a colour mix. So I can obviously mix two colours together. Now if I pipe that directly in the diffuse, you see we get this icky oral colour, which is blended between this colour and that one. Okay, so I'll set that back to there. We're going to use some noises for the bias anyway. So colour mix. Let's find a decently dark. Has to be relatively dark on the first one, and I'm going to go something similar, bit grayed out, and onto the second one. So yeah, I'm going to promote that parameter. I'm going to promote that one so we can do it from upstairs after we've generally built the shader up. Okay, bias. Let's have a look. So we'll go from that to that. So we do have the two colours going in there. So 0.5. Okay, we spoke about rest position. Right, that's a good time to bring in a rest position bob. And turbulent noise again, because they're pretty handy, because it's like several noises in one node. And put the bias in there. So now we are getting some sort of changes to the colouring. So you could even, if you wanted to, grab a normal fall off, and you could do it, you could bias it on the actual normals. If you do invert, then it's a Fresnel effect. As you can see, it's darker there and lighter there, but you might have problems with the colours changing as it's moving through space. Or we can do that. It's not looking a great deal at the moment, but if we go with that, and as you can see, it is actually working. Do that for now until we can figure out excuse me, until we can figure out, you know, how we actually want to mix these two colours. So that's looking okay. Obviously the colour's a little bit on the gaudy side, but that's just for viewing purposes. So let's go back down and let's darken it down, you know, the blend between the colours and whatnot, you know, needs to be fairly subtle, you know. So I'm going to call this primary diffuse mixer. Okay. You know, I could call this primary noise mix. Primary noise mix. Okay, I'm going to shove this surface globals out of the way for the time being. So we've got a mixture of two colours going in there. The most prominent one for me at the moment is the light. So we've got a primary one. So let's get another colour mix down. I'm going to pop that there. So what we've got now is we've got this colour being our primary one, and the secondary one I'm going to give it a green colour. Okay, and again it's going to be dark, and pretty washed out, to be fair, just to give a little bit of little differences in there. So I'm going to get turbulent noise again, put a rest position into there, and this is going to be the bias for this. So as you can see, the colour's changed again, and let's give this something like 5 across the board. You know, I can't really see a great deal in there at the minute, but you know, subtleness is the way forward. I'm going to give us a bit of room here. So that's our Lambert. So before I go any further, I want to bring some displacements into this. You know, just to get, before you start adding different specularities and stuff in like that, I like to see the displacements first, because you can't really get a handle of what's going on without your displacements in there, because it'll look totally different once it's displaced. So again, good old turbulent noise. Okay, rest position, we're going to use you again, because why not? Displace along normal, as we've previously done, amount, but because this is in the shading context, okay, you need to displace the normals, the points and the normals. Okay, what did we just do? We just broke our model. Not really. Basically it's just we haven't set the bounds for this, so what we can do is go to the properties of up and pipe that into there. You're not going to get any change because there's nothing in here. Hit the little cogwheel, rendering parameters, because it's to do with rendering. Now we know we're working with Mantra, so open the Mantra folder. We know we are building a shader, so it's to do with shading, not the shaders itself, shading, so it's shaders. Sorry, talking out my backside. There we are, shaders. And we're looking for displacement bound and space, so change the space, that is actually in as well. And nothing's happened. That's because we haven't done anything with the displacement bound. The easiest thing to do is take your displace along normal, right click, copy the scale parameter and paste that into there, and it's fixed our object. Okay, so these are the two that we're interested in at the moment. So I'm going to go with Perlin noise, original Perlin noise, because it's a noise that I do particularly like, and the scale I'm going to put this in the negative values this time. And I'm going to increase the frequency in this and see what we come up with. That's a bit mental. So let's drop this down. So you know that's looking all right. That's looking all right. I'm gonna reduce this, and then I can up this a bit more. Okay, so what we're getting now is we're getting a frequency of 5 in all 3 axes right across the model. So there's no differentiating between what's going on. But if you remember, this had a very low frequency, so it had big areas. So why don't we utilize that? So let's multiply. Okay, so I'm going to multiply this noise by this one, and hopefully you see we're getting some areas that are displaced, and we've got some flat areas as well. So it just breaks it up, makes it a little bit more interesting. So that's fine. I don't want to go too far with it. Well, whatever. We've got some displacements in there now, so we can, you know, generally start looking forward at what we're going to do. So I'm going to jump back up. Spotlight, I'm going to call it Hero Light for the time being, so we know what the crack is there. So let's give it, you know, 3 or something like that, because light in space is quite bright. And there we go. Yeah, let's make it a bit more interesting. So let's jump inside. And okay, I want some specularity, but I'll go with the specular sheen because I want it kind of falling off on the edges. Now, what's happening here is we've got the BSDF. This is what we're using. This is what's, if you're using BSDF, you're obviously using PBR. Okay, it's your physically based rendering. That's why I've not put this. I mean, if I decide I wanted to go ray tracing, I'd need that in there. Okay, it's not going to affect this, but if I changed over to either micropolygon or ray tracing, if that wasn't connected, then it'd break. And generally, that's it. But I'm going to take that out. No point having that in there because we're just using PBR. So what we need to do is we need to add this in after the lighting has been calculated, because specularity is an added value on top of the lighting. So let's pop that up there, and as you can see, we've got it around the edge. If I take that off and then hit snap and pop that back in, I'll let it do what it's doing, and then go between the two. You see, more interesting now. So sheen, we can increase the intensity, which to be fair I do want to do. I want to get a bit of intensity in there. The index of refraction, if we bring that down, it covers it all. So this is basically like an exponent. It's just drawing it back up towards the edges. You know how much of the edges run off, basically. That's, yeah, it's looking all right to me. Is that? So that's okay. That's fine. It's a bit more interesting. And let's go with specular as well, because we need some, you know, everyday specularity in there. We'll pop that in there. It's going to get a bit bright. It's going to get a bit icky. So let's bring the intensity down, because obviously it's a rock in space. So it's, you know, we're not talking metallic stuff here. That's going to go a bit too bright. Let's lower it down a little bit, just to give it a little bit of something else. So that's looking alright for the time being. We've got, obviously this is our shader, our displacement part of the network. That's our diffuse colour part of the network, and this is obviously the lighting part of the network. I'm going to put some reflections in, see how that kind of fares. Reflections are a bit different. They require a little bit more So what I'm going to have to do is I'm going to get a normalize, so that's going to 0 and 1 the incoming value. I'm going to normalize n, then I'm going to copy paste, normalize I, okay, and this is where the globals are going to come into play. So n into n, I into I. Why am I using I? If you pop that over here, I'll tell you direction from I to surface. So that's why I'm using I. What I need now is a reflect ROP, okay, and it's looking for a direction and a normal. Well, we've just normal. In fact, it's looking for a normalized normal. Okay, normalized normal. There you go. So I'm going to pop that in there. Pop that in there. And then what we need to do is we need to trace the reflection, because this is giving us a direction, okay? And we can put that into the direction of this. And then as we've done before, we'll take that and we'll add it after the light's been calculated. So now it looks a bit different. Take another drink. Looks a bit different, and yeah, it don't look too bad. It doesn't look too bad at all. Just delete mandrel out of there. Just force of habit is that. It doesn't actually affect anything leaving it in there, but I just don't like it with the default environment map in there. With the reflections, again, as I can say, we're using the output of F here, which is your BSDF. Can add, say, a float to a BSDF. Not normally, anyway, that I know of. But as I've said, I'm not no particular expert. But what you can do is you can definitely multiply. As long as you're multiplying the BSDF first, and then you can get a normal fall off and multiply that in, and it won't break anything. It's not going to make much of a difference at the minute because of the fall off that it is at the moment. If you do an invert, it will behave like a Fresnel reflection, so it'll be a bit more edge centric, so to speak. And then your exponent, as I said before, you know how far towards the edges that it's actually going to reflect. As you can see, we're getting a bit of reflection over there, narrowing it down a little bit. So with that, that's all I'm going to do with this shader for the time being. I'm not going to delve massively deep into this because it's an area I'm not 100% sure on anyway. But this is just through faffing about, really. You know, mixing some stuff up and you know see where we go from there. So as far as I'm concerned, that's alright for the time being. We can come back in here and tweak this up at a later date. So let's call that a secondary noise mix. So that's that. Reflect, trace. We don't need to name them because we know what they're doing. This is just main displace. Yep, thought I spelled it wrong then. Main displace noise. So yeah, what I'm going to do is I'm gonna promote that, and do you know what? I'm just gonna leave it for the time being. If I need to jump back in, I'll jump back in. That's not really a problem. Them two are ridiculously close to being the same there. Bit of variation in there. Get a better feel for stuff. So let's go back up to object level. Come back to our scene view, and I'm just going to rotate the camera around. Fire off another quick render. See what it looks like from a more lit angle. Do you know? I don't think that's bad. You see, you've got displaced areas. We've got areas that are not displaced, so the mixing of those are looking pretty good. So, okay, that's one of the tough bits out there. I don't like this overexposed light in here, so I'm just going to put headlight on only, so we're back to the way things should be. Right, next step, planet. Okay, you get a planet through my faffing about over the years. Wrapping a texture map onto a sphere works well at a distance. If you're wanting to do a fairly close-up planet shot of, you know, an asteroid skimming by, that sort of thing, then wrapping a sphere is not going to cut it in the slightest. So I try and do things a little bit differently in that aspect, and basically I use a grid. Sounds crazy, but yep, good old grid. I'll call it planet. So let's jump inside. So we've got this grid, and I'm going to make it ridiculously big. That's ridiculously big enough, I would assume. So let's go back to flat wire shaded. Okay, so here, rows, I'm just going to drag that over to columns and relative channel reference, so we only have to mess around with one slide to update both. I'm going to crank it straight up to 50, just like so. So 935, balls to it, let's make it 1000. Okay, so you could use a twist SOP to do this, but it can be a little bit, you know, I wouldn't say problematic, but you know, it can kind of take you by surprise if you're not entirely sure what you're doing with it. So what we're going to do is we are going to lattice deform this, okay? But we're going to build the lattice deformer. So let's drop a box in, okay? I want it to be a polygon mesh, and I'm going to zoom right into the box, okay? And I'm going to hide other objects because I don't want to see my asteroid anymore. So this is what we've got. I want to make the box obviously on X and Z the same as the grid, okay? So we've got size X and size Y there. So let's do a channel reference, so CH, and go for the grid 1, and then we're going to go size X, okay, tab, channel, hold close parentheses, and let's go with the grid 1 as before, and this time obviously we're going to go with size Y. So what we should have now is we should have the box and the grid exactly the same size, which would do. Fantastic. Okay. The height of the box, you know, just for ease of us actually seeing it, I'm just gonna, you know, increase it up just a tad. So that's fine. So let's get a lattice in here. Okay. So we want to deform the grid, so that goes into the first input. And then what we've got is rest geometry, and we've got deformed. So we'll pop that into the rest because this is the non-deformed box, and then we're going to pop this into the deformed box. Okay, and it's still going to error out. It says rest geometry bounding divisions do not match lattice divisions. And that's because it's on lattice. We want points. Okay, error's gone now, and nothing's happened yet. And that's because we haven't deformed anything. So I'm going to right click on the input of that. I'm going to drop down and edit SOP. And basically what we're going to be doing is we're going to edit the points of the box. So whilst we've got this selected over the viewport, S for select, 2 for points, let's select them, hold shift, let's select them, hit T for the transform tool, and let's bring this down, okay? And as you can see, not a great deal is happening, and that's because we haven't fiddled about with the radius. This is what controls the actual deformation. So let's increase this radius. It's really large, so let's do it by 10, I suppose. Keep going and keep going and keep going and keep going until it's nice and smooth. So we've got a nice, fairly smooth, fairly accurate curvature going on there. So that's okay. That's pretty cool. So what we can do is we can just select this lattice, copy paste it. Okay. What we want to do is we want to put the output of the lattice into the input of this one. Okay. and I'm going to unplug that. Okay, otherwise we're going to be doing a double edit. So I'll put the box back in there. So again, I'm going to drop edit on here. Okay, but obviously I'm going to select points on the opposing edges, like so, and hit the T key. And again, I'm going to pull this down so it kind of matches, you know, the elevation of the other box. And as you can see, it's working straight away, and that's because we copy and pasted it. We've already got the radius value from the previous one, so that's okay. That's pretty cool. Before we put a texture map on this, we are going to need UVs, so we'll add our UVs on the grid there to make sure they also get deformed. So we'll project some UVs on there. Vertices, orthographic, just make sure that's initialized. And if we middle click on here, we now have UV, and we'll come down to here. We still have a vertex attribute of UV, and that is also shown here in our details view. If we go to vertex, there we are, we have our UVs in there. Okay, so that's okay, that's fine. Everything's working as intended so far. And that's all I'm going to do with this at the moment. We can go back in there and alter this. It does look a little bit peculiar in places, but not a problem in the slightest. And as you can see, it's way bigger than our little asteroid sat there, so I'm going to nuke the lights out. I'm going to nuke the camera out as well. So what I'm going to do is I'm going to try and get a decent camera view here, something like that, and then I'm just going to nuke camera like that. Okay, and as you can see, our tiny little asteroid is all over the place now. I'm dragging it about. I hit L to sort that out. So back into the perspective viewport, and cameras are a little camera is a little dot there. I'm going to go to view, and I'm going to increase the scale on this because I want to be able to see it from afar, so I know where my camera is located. And let's go space 2, space 3 into the front here, and let's maximize this screen. Let's add a curve. Okay, why am I adding a curve? You shall see in a minute. So I'm just going to pop one there, one there, and I hit enter. So this curve is actually a straight line. Okay, not the most exciting of curves, I understand that, but this is going to be asteroid path, because we need the asteroid to go somewhere. We'll jump inside. So put those point numbers on. So you can see we've got 2 points in the scene. We've got point 0 and point 1. Now I want this to be a NURBS curve, so it's going to have at least 4 points for it to be able to generate a NURBS curve. So what I'm going to do is I'm going to resample this. And that's a bit crazy. Maximum segments 5. Okay. In fact, 4. So 1, 2, 3, 4, 5. 5 points overall. And now I'm going to convert that into a NURBS curve. Think. And as you can see, if we look here, 1 polygon, and if we look here now, 1 NURBS curve. So we do have a NURBS curve going on here. So let's ghost other objects and go back into the front. Now with this, let's maximize this so we can see what we're doing. I'm going to select this point, hit the T key, and as it's a NURBS curve, we're going to get a nice gentle uplift from here. And let's just try and get, you know, some nice, fairly nice slope going on here. Something we can use. We can definitely use that. Okay, we may need to lift it up depending on how large we're going to scale our asteroid to, meet the thing. So let's look at our camera view. See how far back we can go before we, start to see the edges. It's about there, I would say. I'm going to go back into here and quite possibly turn those point numbers off. This may well be too much, to be honest. Move that up just a tad. Select this. Open the camera. Okay, that'll do for now. So we've got the UVs in here, we've got the surface, let's go material palette. We're going to drag a mantra surface node out here, and I'm going to assign that to the grid. Okay, so I'm going to call that planet. So I'm just going to open an internet browser. I don't need that popping up, and let's bring this over here so we can see what we're doing, and we just go blue marble maps. Okay, browse by collection. Let's find something that we can use. There's no point going for the whole of the world for just the section you're going to be looking at, so you may as well just go to collections and find something, preferably with no clouds, and obviously try and get the highest resolution you can for what we're looking at. So look at this, see that's got quite a few clouds in it. That's got an odd coloured patch in it, I believe. So let's just have a look. Yeah, it's got writing on it and stuff. Let's just have a quick flick through. See what we can see. There's definitely something out here we can use, that is for sure. Mona Island, Crimean Peninsula. So look at this. Don't tell me that's also got the names on it, which it doesn't. It's taking a while to download, to be honest. There are some clouds in there, but they're only tiny, apart from this one here. Yeah, let's have that. Let's put that into pictures. We'll just call that I don't know, image meet Earth. Okay, so planet, use map, and we'll go to pictures, turn off image Earth. So okay, there we go, we now have the image on there. That's fine. I'm going to copy this parameter because we're going to need it very shortly, and I'm going to go into displacement, I'm going to go map, and then I'm going to pop that into the texture path. Okay, so we're in the camera now. I'm going to have it, I mean, this might not be the best map for this. No, let's go back and check it out. So we've got the light in the scene, and let's hit render and see what we come up with. Okay, so that's not too bad initially. So yeah, that's okay for the time being. Let's look through that light again. Yeah, exposure about 3. Not an exposure, an intensity. Okay, that's brightening it up just a little bit. Obviously the displacement is way too much. So material palette, and effect scale, let's take that to 0.2. Now 0.1. No, I don't want it jumping out, so to speak. Got a horrible line going through there, that must be from the texture map. No. So override that. Let's have a look. Nah, it's not the texture map, is it? I know what I've done. Forgot to turn off the asteroid path. There we go. Much, much, much better. So, planet. I'm going to copy paste you, and I'm going to call that environment. I'm going to jump in, and then I'm going to transform you up ever so slightly. So, you know, 0.1 maybe. And let's go to our material palette and scroll down, 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 down. And where are you? Glow. I'm going to put a glow on there. So I'm going to go OBJ, and in here I'm going to change this to glow. And not a great deal going on just yet. So material palette, glow. I'm going to give it obviously an earthly kind of blue tint. Going to invert it as we did before. Okay. And then let's increase the ramp rate just so the glow disappears back towards the horizon. About 10. And then we can add some emission as well, so anything that flies past it's going to get lit up. So that's, yeah, it's a little bit overkill, but we can deal with that. That's not too much of a concern at the moment. So let's asteroid. Let's get back to our asteroid. Okay, asteroid path object, and I'm going to go with asteroid path. So now the asteroid is on this path, and we control it with the position here. And as you can see, our asteroid is ridiculously small. Okay, so I'm going to jump in here and transform this up to a sort of size and scale that will be reasonable. I mean, problem is we're now running through the surface, which is not something we particularly want to do. So asteroid path, you can move up, and let's look through the camera. And asteroid, let's move you back along the path. I mean, I do want it close up to the camera, but we're back now at position 0. So let's come back to here. Let's jump into our asteroid path, and as we were editing before, select this. I'm going to hit the transform. I'm just going to move it back out of the way of the camera. It should be out of view now. See what we get when we so what do we get now? Okay, so this is what we get. Not very good looking, is it? Not at the minute. So drop environment light in there, and let's think about this. The environment light wants to be blue, because obviously it's coming from, well, the environment, funnily enough. 0.1. Okay, so let's have a look at this. If we it's a bit crazy this, because it's position, it's actually going from 0 to 1, but that actually goes all the way up to 10, so we can do 10 rotations of it all in one go. So I'm going to stop that. I'm going to turn off preview and just give me a render of that. For some reason we seem to have lost a lot of our displacements. -1. Yeah. That's insane. What, run the point position into there. What do we come up with now? Not a great deal. Yeah, there we go. Let me pull that out of there. So yeah, we've we've scaled the object up insanely, haven't we? Okay, no, I don't want a sphere. Okay, so that's looking alright. Is that for the time being anyway? So let me just get a decent view here. I'm going to control click spotlight. Okay, and this is going to be Earth floor, and again it's going to be blue, 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 blue. And you're not going to generally see very much of it because it's going to be trying to pass through geometry, and obviously we have shadows enabled. So what we can do instead is we can add a light linker into here, and we can go Earth glow. I want it to do with the asteroid only. So let's come back to asteroid, put it there, and render this out. As you can see, we're getting some blue light under here, which you'd expect from the environment. So let's stop that there. Let's just take a smidgen. Earth glow. 2, 3. Not getting any more intense. 10. Oh, it's definitely working. You can see it. So that's okay. So with this, I'm going to go, we are on frame 1, so asteroid, set that to 0. I'm going to alt click that, 240, so that's 10 seconds of animation, position 0.99, and then alt left click that, and let's real time it, play once, see how fast it's going past. There is a bit of a lump in that curve, but that's okay. So shift middle click on the position and it brings up the curve editor, space G. So I'm just going to grab all the curve itself and this Bezier function. I'm just going to put it into linear because I don't want it to speed up and slow down. I just want it to travel at the same speed. And let's have a look, to there. Let's have a look at this roll. So it's, can roll it that way. So if I go $FF times 0.1, I mean, that too much? Too little? I mean, this is supposed to be a large rock, so get a bit of roll there. Obviously, that I don't like that the way that curve bobs up, but we can deal with that. Asteroid transform 43, 40. I don't think it needs to be as big as it is. $35 maybe. See how it's looking from a distance. That's looking okay. Select the camera and I'm going to rotate the view just a little bit to get a more interesting camera angle. Obviously I'm going to have to tweak it a bit now because the bottom corner was showing, but that should be okay. So now it's coming in at the corner of the screen. We'll fire off a quick render, see how that looks. None too bad. I don't think that's looking bad at all, to be honest. Oh, apart from that kink. That kink. In fact, I don't think that's kink. I think that's the corner of the grid, to be honest. But yeah, that's looking pretty good. What I'm going to do is I'm going to bring this to a close, and I'll come back in part 2, and we'll add a bit more visual interest to this asteroid. I mean, I hope so far it's been, well, enjoyable. If not enjoyable, maybe you've learnt something from there. If so, if you thought it's been alright, just, leave us a like, helps me out a lot. If I know you guys are liking what you see and stuff like that, I can delve into other stuff, make some more tutorials and stuff like that. But that's down to you guys. So yeah, if you've enjoyed it, then support me, hit me with a like. With that, I'll pull it to a close, and thank you for watching.